All right, system of nonlinear equations. Now, the two rules still apply. It just means that when you combine your equation together, you're going to have a different type of equation to go ahead and complete. So, for example, my y's are opposites of each other. That means I can add these together to create a new equation. Now, the x's don't combine together because I have an x squared and I have a minus x, so don't combine them together, but I can still add them together to create a new equation. So adding them together, I'm going to get x squared minus x negative y plus y, right? But those end up canceling out. And then it's equals to negative 2 plus 2, which is 2. Well, this leaves me with a quadratic equation. How do I solve quadratic equations? I want it to equal 0, so I can subtract the 2. And now factoring a times c, factors that add to b, you get x minus 2 and x plus 1. So set each equal to 0, you get x equals 2 and negative 1. So now you can plug it back in to find your y value. So if I plug in 2, you get negative 2 plus y equals 4. Add the 2, y equals 6. So my one pair is 2, 6. Now I can plug in the negative 1. So negative times negative 1 plus y equals 4. That's 1 plus y equals 4. Subtract 1, you get y equals 3. So then it's going to be negative 1 and then 3. Now you can also use the substitution, and if you feel that sometimes a substitution is easier, you can also do that. So for example, if I wanted to get y by itself, because I see y's in both equations, I can add x to the other side, so I get y equals negative 1 plus x. That means I can substitute in to the other equation, so I'm going to get x squared minus 1 plus x equals 5. So this is going to be x squared plus x, subtract 5, so I get minus 6 equals 0. This factors. A times c, factors of negative 6 that add to positive 1 would be positive 3 and negative 2. So set each one equal to 0. So now to find my y values, you want to plug them back in. So I can plug it in here. So negative 3 plus y equals negative 1. 3 plus y equals negative 1. So subtract 3. So I get negative 3, negative 4. Now if I plugged in 2, so I get negative 2 plus y equals negative 1. Add 2, you get y equals 1. So you get 2, 1. When x is 2, your y is 1. Now for a question like number 4, you would probably only use elimination here. And so adding these together, right? Because you can think of these as its own variable, x squared and y squared. But I have positive y squared and negative y squared. So if I add those together, you get 2x squared because there's 2 of them. Those cancel out and it equals 18. Divide both sides by 2. Square root both sides. You get x equals plus or minus 3. Plug back in. Dot, dot, dot. Now, because you have a y squared, that actually means that if I plug in 3, you're going to get probably 2 y values. So there should be 4 values as part of your answer. Now for number 5, it says match these. Okay, so there's different ways you can do it. You can graph each one. That's fine. You can find the solution to one of them. And if you find the solution, then you can compare it. Whichever way you feel is better or which one's easier for you, go ahead and do that. So like for example, on this one, if I were to plug it in here, I could do substitution. So I get x plus x minus 8 equals negative 2. That's 2x minus 8 equals negative 2. If I add 8, I I get 2x equals 6. So I get x equals 3. Now if I plug that back in, right, y equals -5. So my solution is 3, -5. So I need to find which one has a solution of 3, -5. No, 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 yes. So I can say that this one is going to be C. It says if the graph of a system of equations is a pair of parallel lines, then the system of the equations is inconsistent. This is mostly true. Inconsistent just means that they don't intersect. I mean, so technically this, because it's mostly true, it should be false. But the idea is, because it's saying if I have two pairs of parallel lines, well, they're never going to intersect. Great. But what if the two parallel lines are the same line? Well, they're intersecting infinitely, right? So that's the nuance here. So the exception is the same line. So you could actually answer this as false and then state that that's the exception. You could say that this is mostly true and state that that's the exception. If we obtain the equation 0 equals 0 using elimination method to solve this system equation, it has no solution. That is false. 0 equals 0 equals its infinite solutions.